Topic which we are studying is growth of ice on lake. Okay, so consider this is the ice which is formed on the surface of a lake. In polar regions we see only ice only, and below that ice again you can find water. Okay, so already we studied the density of ice is less than density of water. So ice always floats on the surface of water. Okay, so density of water is how much? It is 1000 kg per meter cube. This is the density of water. Okay, whereas density of ice is only approximately 910 kg per meter cube. This is the density of ice. So ice definitely floats on the surface of water. Okay, now see. So Seema, this is ice, and atmosphere temperature is less than 0 degrees Celsius. It may be -1, -2, -3, -4, -10, -20, anything can be present. Okay, and ice also can be at any temperature. Are you able to understand? But the water which is present below ice, definitely it will be at 0 degrees Celsius. That's it, no? Because when temperature goes beyond 0, that is when temperature reduces beyond 0, it forms into ice. It has still not converted into ice. It means that its temperature must be 0. That's all, no? Because when it is temperature reduces beyond 0, water converts into ice. So ice temperature can be anything. It may be -2, -3, anything. And atmosphere temperature also should be less than 0. But the water just below the ice, it must be at 0 degree Celsius. That is one point which we can understand, no? So therefore, what can we write here? As water freezes at 0 degree Celsius, clear, no? So water below ice should be at a temperature of 0 degree Celsius. That's all, number. So therefore, atmosphere is less than 0, but water below the ice is at a temperature of 0. So what is the direction of heat energy, ma? Heat energy flows from which direction to which direction? Heat energy definitely moves in this direction, no? Because 0 is at a higher temperature, -5 is at a lesser temperature. So this is the direction of heat energy flow. Okay, and what is the initial thickness of ice? Initial thickness of ice I have taken y. So let y be the thickness of ice. Okay, therefore what is the amount of heat energy that can flow? So Q is equals to Ka into θ1 minus θ2 into T divided by y. Can I write like this? Correct only, no? This is the amount of heat energy which can be traveled, no? And y means what? The thickness of the cube. Here ice is the thickness, no? So it is having a thickness of y. So K is the coefficient of thermal conductivity of this ice. A is the surface area of ice. Clear, no? θ1 minus θ2 is the temperature difference, and it is the amount of time for which this heat energy is flowing. Are you able to understand? Now let us see what is θ1 minus θ2. θ1 means the temperature here, no? The temperature from which heat is traveling, that is θ1. Temperature to where heat is traveling, that is θ2. So θ1 minus θ2, 0 minus of minus theta will be how much? Theta. So this is the temperature difference between water and the surroundings. Are you able to understand? Okay. So therefore, what is the small amount of heat energy that can flow in a small amount of time? Okay, ma? So I will write here. So small amount of heat that can flow in small time. Okay, how can I write this one? Small amount of heat means I can write dq, no? Differential amount of heat energy, very small amount of heat energy. So this is equals to Ka into, instead of θ1 minus θ2, I can write theta multiplied by time is also very small, no? So dt divided by what is the thickness of ice? Thickness of ice is 1. So this is my first equation. Are you able to understand? Okay, ma? Now see. So when heat energy travels from water to atmosphere, then immediately what happens to the energy of this water? Now heat energy is traveling from 0 degrees water to climate, no, to the atmosphere. Are you able to understand? So what happens to energy of water at 0? Energy of water, will it increase or decrease? Energy decreases, no? Energy means which kind of energy? Heat energy. So when heat energy reduces below 0, then that water, it converts into ice. That's all, no? Clear, no? When you supply heat energy, ice will start melting. When you take away heat energy, water converts into ice. This is what should happen. No? Therefore, the water at 0 degrees Celsius below ice converts into what? Converts into ice. Are you able to understand now? Because it is losing energy, no? Because it loses energy, it converts into solid form. So water at 0, it converts into ice. It means a new layer of ice will be formed. That's all. No? So therefore, what happens to the thickness of this ice? Thickness of this ice increases. So therefore, new layer of ice will form, and thickness of ice, what happens, ma? Increases. So this is what happens, no? So when ice is forming, is it the condition of a change in temperature, or is it the condition of change in state? It is the condition of change in state, no? So Q is equal to ms delta T or ml? Ml. So therefore I will write the amount of heat energy passed is equal to m into L. That's all, no? Clear, no? So I am taking very small time, no? Time interval is very small. So amount of heat transferred also will be very small. So therefore, the amount of water which converted into ice is also very small. Ashish Vidyarthi unnavu mana lokamlone? No. Are you able to understand, ma? So what is m here? Mass of water which converted into ice, no, ma? That is also very small, because time we have taken very small, no? So therefore, what I can write? I can write dq is equals to dm into L. This is what I can write. Are you able to understand? Okay. So dm, we know that density is equals to mass by volume, no? So therefore, mass can be written as density into volume. So dm can be written as density into dV. I can write like this, no? Small amount of mass, the small amount of volume of ice which is formed. Okay. Next, volume can also be written as, I will write here, okay, ma? So volume can be written as area of cross section into length, no? This is how I can write volume of any body, no? Area of cross section multiplied by length is called as volume. Are you able to understand? So therefore, small amount of volume dV can be written as A into dy, no? Can I write like this? What is dV? The small volume of ice which is formed. Okay, A is area of cross section of the ice. That remains constant. Area of cross section of ice remains constant. But what is the new thickness of ice formed? New thickness of ice formed is dy, very small amount of thickness. Are you able to understand? So therefore, dq, how can I write? dq can be written as, instead of dm, what I can write? So density into volume. Volume can be written as A into dy multiplied by L. I can write like this, no? Are you able to understand? So therefore, here already I have written one equation for dq. So this is another equation for dq. What is this dq? The amount of heat energy which has passed in terms of coefficient of thermal conductivity. Okay. Now what is this dq? This is also the same amount of energy passed, but in terms of L, coefficient, latent heat of fusion. Are you able to understand? So this heat energy and this heat energy, both of them, they are same, no? So just equate both of them. Clear? So let it be my second equation. So this is my first equation. So first equation and second equation, both of them, they are same. So equate them. Okay. So Ka into theta into dt divided by y is equals to rho a dy multiplied by L. This is how I can write. Now what are the terms which can get cancelled? Area of cross section, the area of cross section will get cancelled. So I want to calculate a time of formation. So to form a particular thickness of ice, what will be the time taken? That I want to calculate. Clear? So take dt on one side, you send all the values to the other side. So therefore what I will get? Dt is equals to rho y dy L divided by k into theta. This is what I will get. That's all. First make a note up to here. Is equals to rho means density of water, y means thickness of water, dy means a change in thickness of water, that is ice. Clear? L means latent heat of fusion, k means coefficient of thermal conductivity, theta means temperature difference. Clear? No, all values? Now see. So this is dt, no? dt means very small amount of time. If I want to calculate a time to form y thickness of ice, okay? So time taken to form y thickness of ice So that is 0 to y if I want to calculate. What is meant by 0 to y? Initial thickness of water is 0 and I want to form y thickness of ice. Understood, no? Therefore, I have to integrate on both sides. No? Integration of dt is equals to integration of, so rho y dy L divided by k into theta. This is what I have to write. And what are the limits I have to take? 0 to y, no? 0 to y, and time taken is 0 to t. So integration, differentiation, they will get cancelled with each other. So therefore, t is equals to, now here what are the terms which are constant? Rho L by k theta, they are constant. So integration of y into dl, limits are applied from 0 to y. This is how I can write now. Now integration of y is how much? Integration of y square by 2. So therefore, t is equals to rho L by k theta multiplied by y square by 2. And if you supply the limits also, then again I will get the same equation. Okay. So therefore, time taken is how much? So rho L y square divided by 2k into theta. Clear? So this is the time taken to form y thickness of ice. Are you able to understand, ma? So to form y thickness of ice from 0 thickness, it means initially there is no ice. Okay. So to form this much of thickness of ice, this much will be the amount of time taken. Are you able to understand, ma? Make a note. Clear? Now, from this information, I can write one more inference, ma? Y thickness. To form y thickness of ice, this is the time taken. Any values you can calculate, no problem. dl I have written. This is dy, ma. Okay. Now see. So therefore, ratio of times taken to form y, 2y, 3y, 4y thicknesses. Okay. Times taken, t1 is to t2 is to t3, and it goes on, is equals to. So time is, see here one thing which I can write is, time is directly proportional to y square. No? Clear, no? Remaining all terms, they are constant. Remaining rho, L, 2, k, theta, all of them, they are constants. So as the time increases, the thickness of ice also will increase. So time is directly proportional to y square. So therefore, to form y, 2y, 3y, 4y thicknesses of ice, what is the time taken? So it will be equal to y square is to 2y whole square is to 3y whole square. I can write like this. No? All y values, if they get cancelled, then what is the ratio of times taken? t1 is to t2 is to t3 is equals to 1 is to 4 is to 9, and it goes on like this. Okay. So this will be the ratio of times taken to form y thickness, next double thickness, 2y, 3y, 4y, like this. Are you able to understand? So it is in the ratio of 1 is to 4 is to 9 is to 16 is to 25, like this the ratio will go on. Understood, Amma? Okay. So now I will write one more case. Case is that, so if already there is some thickness of ice, okay, ma? Then time taken to form additional thickness. Okay. So here what is the condition I have taken? Time taken to form y thickness from 0 thickness, no? So limits of integration I have taken 0 to y. Okay. Initial thickness is 0, final thickness is y. So sometimes he will ask question like this also. Already there is some thickness. Now I want to form new thickness of ice. Then what I have to do? Can you say, anybody? So just you change the limits of integration. So previously we have taken 0 to y, no? Now you take from y1 to y2. That's it. Understood? No? So therefore, how can I do that calculation? Let us see. Okay. So therefore, how can I do it? So time taken is equals to, so rho L by k theta, integration applied from y1 to y2, y into dy. This is what I have to do. Okay. So if I do this one, then what I will get? So rho L by k theta multiplied by, so this 2 I will take here, ma. So I can write y2 square minus y1 square. This is my answer. Okay. So integration of y is y square by 2 only, no? 2 I am taking outside, but now I have to apply the limits, no? So initial limit is y1, final limit is y2. So first you write final limit minus of, then you write the initial limit. That is the method of integration, no? So this is the time taken to form y2 thickness from y1 thickness. Okay? Now here also, if I want to take the ratio of times to form, okay, y from 0, 2y from y, 3y from 2y, and it goes on like this. What is the meaning of this one? So to form y thickness from 0 thickness, okay, then 2y thickness from y thickness, then 3y thickness from 2y thickness, okay. Then for this one, how can I calculate the time? T1 is to T2 is to T3. It can be written as, first I will take 0 to y. So therefore y square minus 0 square is to, then 2y and y. 2y whole square minus y square. Then I will take 3y whole square minus 2y whole square, like this. This is the ratio I have to take, no? So if I do this total calculation, what I will get? So y square is to 3y square is to 9 minus 4, 5y square, like this it will go on. So y square, y square, y square, you can cancel them. So they are in the ratio of 1 is to 3 is to 5, and it goes on like this. Understood, number? Clear? So time taken to form y, 2y, 3y, 4y from 0 thickness. For that one, time taken is 1 is to 4 is to 9 is to 25 is to 36. Understood, no? But to form 0 to y, y to 2y, 2y to 3y, 3y to 4y, this is the ratio. 1 is to 3 is to 5 is to 7 is to 9 is to 11, like this.